All right, ladies and gentlemen, this is a video on the homework for estimation and using the TI calculator. So, okay, let's read the first question here. Now, it says use the given degree of confidence and sample data to construct a confidence interval for the population proportion here. Population proportion P. Now, what that is this is code for estimate a proportion. So you're going to estimate P. So remember your format. And this is going to be the format that's going to be used because the first four questions here, 1, 2, 3, 4, these are all about estimation of a true proportion. Okay, so you should see that phrase everywhere here, to estimate a true population proportion. Estimate, use the confidence interval for a true proportion. Confidence interval for a true proportion, that's estimate P. So that's what you're going to see here for the first four. Now, as you read, it says here a survey of 865 voters. So this here is N. In one state reveals that 408 are in favor. Now, that's successes. That's X. 408 are in favor of an approval for an issue before the legislature. Construct, here's what they're going to say. The 95% confidence interval, well, that's the confidence level for the true proportion. Well, that's estimation of P. So I just want to put that together for all of you. And know that I actually started here, this first question here. And remember the definition of a sample proportion. It's the number of successes over sample size. So they told us there are 408 people in favor of the bill out of 865. And that's going to be a sample proportion of about 47.2%. So this is all the sample data that we need. Now, we're going to use the TI calculator here. So in order to use the TI, it's important for us to know, let's see if I can clear this out here, know really what we're going to look for. Okay? So let's go to the TI now. And remember, this is going to be stat. And I believe it is calculate. This is estimate a what? A true proportion. So it's one proportion Z interval. Right here. One proportion Z interval. So I'll put this down. One proportion Z interval. And this is what you enter in your TI calculator. Okay, so one proportion Z interval goes in the TI. Okay, and then we're going to enter all the information we had. Like the sample size again was 865, 408 successes, and this is a 95% confidence level. So, okay, hit enter. And now the number of successes here is 408. Sample size, ladies and gentlemen, is 865. And we already have the confidence level of 95. We just hit calculate. And so, ladies and gentlemen, taking a look here at the top numbers, we're going to get our lower bound estimate and the upper bound. So the lower bound value here, based on the TI, right, is going to be 0.43. We're going to go to the nearest thousands. 8 less than P less than 0.50. Looks like that's a 4. The digit to the right's a 9, and that'll make it a 5 here. So we now have our lower bound estimate, our upper bound estimate, and we can say this is good for the 95% confidence level. And so, yes, ladies and gentlemen, 43.8% and 50.5% are in favor of this particular bill, whatever this bill is. So this is how we answer question number 1. Now what I'm going to do here today is I'm going to do the odds. 1, 3, 5, 7, 9, and so on. But let's take a look and see if we should fire the publisher, right? What do they give us for question 1? It looks like we're okay. Question 1, ladies and gentlemen, we got the same answer. All right, that's good. Okay, so let's take a look at question 3. We're going to do the odds, ladies and gentlemen. You could do the evens here. So let's read question number 3. And when question 3 says here, there's 297 college students that are randomly selected and surveyed. 126 own a car. So my N from the sample is 297. We had 126 successes. They owned a car. And they want us to use the 99% confidence level. They're going to say, find the 99% confidence interval for the true proportion again. Okay? So again, it's the sample proportion minus your error. Oops, that's not sample proportion. It's your sample proportion minus your error less than the sample proportion, right? This is plus the error, so we have a lower bound and an upper bound again. So let's remember the data here for number 3. 297, 126, 99. 3. Sample size was 297. I remember the confidence level was 99% confidence level. Let me change that color. Right, for number 3. We're going to write down the sample information again. N and X. And I'm going to move this confidence level down here. So go back. Number 3 here. 297, 126. All right, so sample proportion again, by definition, is 126 successes out of 297. And let's see what this is approximately, because I want to know what the sample proportion is, the point estimate. 126 divided by 297. And ladies and gentlemen, we get approximately 0.424. All right. Okay, 0.424. Now, we're going to enter all of this information in the TI. Okay, so we're going to hit stat test 1 proportion z interval. Okay, 126 successes. Oops, let's go back and delete that. That's out of 297, ladies and gentlemen, sample size. They want the 99% confidence level. So we're going to go to the nearest thousands again here for number 3. So we should have 0.350 less than the true proportion, less than 0.424. Let's double check. 0.424. All right. Well, this is what I have here for a lower bound, and this is what I have for an upper bound. Something's bothering me about this one here, ladies and gentlemen. Something's bothering me. All right, because the sample size is 297. I apologize. Let's go back here to the TI 0.35. So that's 0.498. I was looking at the wrong thing. That was what was bothering me. So the upper bound is 0.498. I apologize. So the upper bound value, and we can say this with 99% confidence. Okay, let's look at everything here now. Number 3. All right. Number 3. Let's see if we should fire the publisher. So for number 3, sure enough, the answers are 0.350 and 0.498. So we are okay for number 3 as well. Okay, good. Okay. Number 5 now. Let's take a look at what's happening here. They want us to find the confidence level for sample data. Find the confidence interval for estimating the population mean. Now, population, this is really estimate. We're going to be estimating mu. Okay, and now let's read what it says here. And this is what we're going to be doing for question 5, 7, really 6, and 8. They want a confidence interval for the mean mu, confidence interval for the true mean. Okay, what is 95% confidence interval for the true mean? 90% confidence interval for the mean score mu. Okay, they didn't write it as true, but fine. Those publishers. So questions 5, 6, 7, and 8, they're all estimating the true mean, ladies and gentlemen. So once again, I'm going to do the odds. And you can do the evens. Okay. So let's read. Random sample of 78 light bulbs. So this is my N here. And has a mean of 409 hours. That's a mean lifespan. So, okay, they gave us the sample mean here. We don't even have to label it. Look at that. They labeled it for us with a standard deviation sigma of 37 hours. So this is known from, a past sample, or just sort of that issue is known. The standard deviation is known. Okay. Now what do they say? Construct the 90% confidence interval to estimate really the true mean. They didn't say that, but that's what this is. Those publishers, okay? I understand. You say, boy, they're not really clear. I agree. 90% confidence level. Okay? Because they told us. So this is number 5, and I'm going to have to use my scratch. And I already forgot, but in our sample, they gave us a sample size, and they were nice enough to compute the sample mean. And I believe this is the 90% confidence level for number 5. Okay, sample size is 78, and the mean is 409 hours. All right, this is number 5. Now remember, the format is the sample mean minus your error, less than the true mean, less than the sample mean plus your error. Remember, we're trying to get a lower bound value and an upper bound value. We're going to use the TI. And the TI here just requires that information here. But remember what you use, right? I don't even remember. I'm going to have to look at the calculator. Let's see if you guys remember this. We're going to have to go to stat test. And it looks like it's going to be, I think it's the one. This is a mean. Is that right? Is it the Z interval, I believe? Number 7, right? Large sample. Use that Z. I believe so. Z, and it's an interval. So Z interval, large sample. Okay. We're on stats, the standard deviation that's known. I don't even think we wrote that down. Let's go back. What's the standard deviation for this? This isn't the scratch. Okay. 37 hours right in here. That's known. Okay, fine. So standard deviation is 37. The sample mean was 409. They gave that to us. The sample size in this case is 78. And then this is the 90%, I believe. Yeah, 90% confidence level. So we're going to hit calculate. And ladies and gentlemen, this is our answer here. The true mean is between 402.11 hours, is less than the true mean, which is less than 415.89 hours, ladies and gentlemen. So here you go. There you go here. And we can say this with 90% confidence. And this is how we answer question number 5. And let's see if the publisher for number 5 is correct. And it looks like they went out to the whole number, 402 to 416. Yeah. And of course we didn't see that coming. I mean, but that's simply, if we approximated our answer to the nearest whole number, it will be between 402 and 416, okay? I wish they would have told us that to begin with, approximate your final answer. But as you guys can see, 402, 416 to the nearest whole number here. So we're good with that one. That's number 5. We write down number 7 here now. Okay. Number 7, final answer to the nearest tenths, by the way. So let's try this one here. Okay, number 7 here. Well, I don't want to erase it. What do they say? 43 packages are randomly selected and received by a parcel service. The sample has a mean weight. So the mean weight right here, this is 12.5 pounds. That's a mean from a sample. So that's a sample mean, 12.5. And a sample standard deviation, 3.6. What is this is now the 95% confidence interval, which is meaning confidence level. So I'm going to write it down here. Now this is estimating a mean still. Okay. There we go. Let's write everything down. Sample 73, 12.5, 3.6. 73, 12.5, 3.6. 73, 12.5, 3.6. This all came from the sample. And don't forget, we need a particular confidence level. And the confidence level here was 95%. So, all right. So we're going to enter all of this information in the TI. Let me get a drink here. Okay, TI. So in the TI, we're going to say, okay, what do we do? Stat. Now this is test. This is going to be estimating a mean. So we're going to go to, again, number 7, Z interval. This is estimating a mean for a large sample. So we're on stats. Standard deviation is 3.6. Sample mean is 12.5. Sample size is 73. Confidence level is 0.95. We're going to calculate that. Okay, remember, I think they went out to the nearest tenths on this one when I looked at the solution. So let's go to the tenths here. The lower bound is 11.7, looks like. And the upper bound, if we go out to the nearest tenths, is 13.3. You say this with 95% confidence. Okay, so let me share with you this. And let's see if, in fact, they're correct. That was number 7. 11.4, 13.6. Something's a little bit off. I think we got 11.6 less than mu, less than 13.3. So double check, ladies and gentlemen. So far, this is where we're up to. Okay. 73. Number 7 here. Number 7 is bothering me. That's 43 packages, not 73 packages. So let's try that one again. Let's try it with 43 packages. Stat, test, Z interval number 7. So we screwed up on this one. There was 43 packages, not 73 packages. Okay. 11.4, 13.6. So go back over here. There was 73 packages, not 43 packages, not 73. That's the N. All right, we made a mistake. If I find it, it's not a mistake. So look at the TI now. So in our scratch paper, let's change this. 11.4. And 13.6. Okay, we get to keep the publisher. Okay, so you have the lower bound, the upper bound. So the publisher was correct. $11.4 and 13.6. So far the publisher's right on. Okay, and I'm going to remark here about the next two. The next two, we're estimating, look at, I'm doing the odds now. This here is estimate the sample size. Right? They're saying find the minimum sample size. That's estimate N for a new study. And I did that one in class. So I'll say see your notes. And in fact, I did number 11. This is also the same situation. Estimate, what do they say? Find the minimum sample size. They actually put it up here. You know, they phrase it there. Estimate N. We did this one in class. I'll say see your what? See your notes here. So 9 and 11 we did in lecture. See your notes. I'm going to go to number 13 now. Now let's take a look at number 13. What are they saying? Use the given degree of confidence and sample data to construct a confidence interval. Okay. for the population mean mu. This is estimate mu now. So let's be smart. Let's see what's going on here. Okay, so what does it say? So we're going to estimate mu for question 13, 14, 15, 16, 17, and 18 here. For all of these questions, we're going to estimate mu. Okay? But of course, I'm only going to do the what? I'm only going to do the odds here. Now, when I read the question 13, what does it say? It says 30. Randomly selected students took the calculus final. The sample mean is 77, and the sample standard deviation is 6.7. So what I'm going to do here for you guys is this. I'm going to stay here on this page, and I'm going to say here, here's our sample information. Sample size is 30. Sample mean is 77, and the sample standard deviation here is 6.7. They want the 99% confidence level. I know they say confidence interval. Same thing. Okay, and it's for the mean for all students. Estimate mu. So they don't use the language I use. I will always use the language I've been talking about in lecture. But I want to go over this because, like I said, sometimes students read this and they say, I don't even know what's going on with these kind of questions because it sounds different than yours. So I want to go over that, and that's why I'm doing this. I'm going over it with the TI, though. Okay. Drinking some Gatorade. Here we go. We're going to use the TI. However, this is going to be, don't forget, this is less than or equal to 30. That means these are all small samples. You're going to see that these questions are going to be small samples. Sample size is under 30. Now, remember, we'll have to use t-interval. T, small sample, t-distribution, student distribution in our TI. T-distribution, so we're going to go to stat, test, number 8 is t-interval. Okay, now put the sample mean in. 77 was the score. Sample standard deviation is 6.7. It's how consistent. The sample size is 30. Confidence level is 99. So we got the 99% confidence level. We're going to hit calculate here. And I think we're going to go out to the nearest, I don't know, we'll go out to the nearest tenths for number 13 here. So number 13, if you want it, we'll go way down here and go, hey, oh, they actually went to the nearest hundredths in number 13, in case you guys didn't know, way down here. Number 13, right? So, we'll look at it the way you would normally as a student. So if I go back to the TI and say, okay, 73.63 less than mu less than 80.37 here. And that's what the calculator says. And this is what both the solution and the calculator say. Lower bound, upper bound. So we're checking this like we'd really check our homework. Number 13. All right. let's say number 15 here. Okay, number 15 says the Savings and Loan Association needs information concerning the checking account balances of its local customers. Here comes your sample information. You say, how do you know? It says a random sample of 14 accounts. Boy, that's small. Sample size is 14. Checked and yielded a mean balance. This is a mean. It's a sample mean of $664.14. So I'm going to start to write this down here. Sample size was 14. Sample mean was $664.14. And then they're going to have to give me a sample standard deviation, and they do. 297.29. 297.29. That's not consistent. Right? It's pretty big. It's not small. And then they say find the 98% confidence interval. Well, that's the confidence level is 98%. Okay? Now, it's kind of funny because it says confidence interval for the true mean. So, you know, just to kind of be consistent, this is the interval people used to have to compute in the old days. It still is done this way, but we're using TI information now. So let's go to the TI and enter this information. All right? You say, what am I going to enter? Sample information, confidence level information in the TI calculator. So, stat, test. This is a small sample, so we go to T interval. Okay, T interval. Now, keep it on stats. The sample mean was 14. Or actually, I apologize. It's not 14. It was $664.14. Sample standard deviation was pretty big. 297.29. And then the sample size was, in this case, 14. Yeah, change that to 14. Confidence level, ladies and gentlemen, is 98, so 0.98. Calculate. Now, for number 15, again, I don't know what they went out to. But if I scroll down to the solutions here for number 15, looks like they went out to the nearest penny because that's in the hundredths position. So let's do the same. Nearest hundredths. 453 point, looks like it's 5.6. Less than mu, less than 874.72. Okay. My lower bound value, my upper bound value, and let's make sure we don't get that upper bound value, and then take a look, number 15. It looks like that's the answer that we're supposed to get, 453 point. And let's say we're off by a few pennies again now, so that bugs me. Number 15, remember, if I find the error, this is what you would do in real life. 98% confidence. What do they say? Sample size is 14. Sample mean was 66414. 29729. 29729. Let's see. Is this what we put? 66414. 29729. Sample size is 14. 98. Looks like we're good, ladies and gentlemen. So we are good. Just want to let you guys know. Okay, so, this is number 15. So I'm correct. Let's go to the iPad. 15. Say, Mr. Judge, they're off by a couple of pennies. Okay. I'm going to erase this. All right, let's go to the next one. And ladies and gentlemen, number 17 is very interesting again. If you take a look at what they're saying now. This is the amounts in ounces of juice in 8 randomly selected bottles. 8 bottles. So this is my sample size. N is 8. Now look at this. They gave us the data now. That's 1, 2, 3, 4, 5, 6, 7, 8 data values. Sure enough, they did give us 8 data values. Okay, they gave us data. And they want us to construct a 98% now confidence interval for the mean amount. This is estimating the true mean. Okay. And like I said before, the format is going to be the sample mean minus your error, less than the true mean, less than the sample mean plus your error, like we've been doing. However, this is interesting because they gave us data values. So they gave us data values. So if you guys remember what you do in the TI calculator, right? I don't even remember. Is it stat, edit? And I'm going to put this, I'm going to clear list 1 up. I got to enter this data in a list, if you guys remember. So I'm going to clear that out, go up to the name and hit clear. Now go back. Now I am free now to enter all of that data. So I'm going to do it by the row, 15, 15.5, 15, 15. Okay. 15, enter. 15.5, enter. 15 again, and another 15. So this is my first 4 values. It's my first row. And then I have 15.3, 15.3, 15.6, and another 15. So I'm going to enter that in too. 15.3, enter. Another 15.3, enter. 15.6, and then straightforward 15 again. So this is all of the data, the 8 data values here. Now, remember what I have to do for 17 here. Now, in some ways, ladies and gentlemen, this is a small sample again. This is N is 8, small sample, 8 data values. So what we can do, ladies and gentlemen, we can go now to stat again. Go to test. This is a small sample, Z, not ZT interval, number 8. Okay, sample size is 8. Now, instead of being at stats, hit data. Now, the thing about that is that it's going to be data from list 1. That's what you want to use. That was the name of the list. You keep this as frequency 1. I don't even know what that means. And it is still, or I should say, this question is a 98% confidence level question. Okay? So we're kind of lucky in the TI because it already has 98%. All we got to do down here is go to calculate and enter. And so notice the information that it gave me for number 17 here. I'm going to go to my scratch work, or you know what I'm going to do? 17, I'm going to go all the way down to the answer step in the iPad. But this is number 17. Now notice what the answer is in 17 here. I'm going to highlight 17. Now, the TI gives me all kinds of information. The TI says the sample mean, we'll go to the hundredths, is 15.21. Sample standard deviation, go out to the thousands, 0.247 here. The sample size is 8. Okay? So this gives me the sample information, even though I didn't ask for it. But it also gives me the confidence level information. 14.95, less than mu, less than 15.475. Okay? Now, if I go here to the answer for 17, you go, it's slightly off again, Mr. Judge. Yeah, it will be because your calculator, the TI, is more accurate than this spreadsheet. Not spreadsheet, this homework sheet. The calculator is newer technology. It's more accurate. We didn't use a table. So if we had to use a table, ladies and gentlemen, you'll actually get slightly different answers. So they went out to the nearest, looks like they went out to the nearest hundredths position. So this will be 14.95. There's no other data there. 15.48. And this is your new lower bound value and your new upper bound value. So wrong, wrong. And so, ladies and gentlemen, this is question number 17. And there you go. This is what you want to have as an answer. All right. Now, let's see. What I want to say is questions number 19, 20, 21, and 22. These are questions about estimating the variance and standard deviation here. And that will be coming shortly in your future. So I'm going to stop right here and I'm going to upload this to my website. So this should be enough to get you guys started on your estimation homework.